Hello average engineers, it's been a little while since I had a video out. I thought I would talk about an interesting project I worked on recently, and it was kind of centered around the minimalist data stack, a simplicity in data engineering, and it has to do with AWS Lambdas, DuckDB, and Delta Lake. Now you know there's been a ton of stuff written about keeping it simple and designing data systems, and you know we're always striving for a simpler modern data stack. The more complex things are, the more they cost, the more the infrastructure cost goes up, the more the maintenance cost goes up. So we're always looking for ways to reduce complexity while at the same time providing top level service. The idea came to me lately because I've been doing a lot of work around lake houses recently, especially around Delta Lake, although this could apply to anything like S3 tables or Iceberg. Anyways, I was thinking about Delta Lake as a lake house and thinking about some heavy solutions that we're all used to, things like Snowflake, Databricks, etc., BigQuery, Athena. Got all these big tools for big data processing. After reading some stuff recently about people using very simple techniques to basically process large amounts of data, got me thinking, why not combine something super lightweight in the infrastructure space like a Lambda, an AWS Lambda? Why not pair that with a super simple tool, something like DuckDB, and can we use it to write into a lakehouse like Delta Lake? And that's exactly what I did. So the idea you can see from this picture is very simple. It's really using data storage for Delta Lake as Amazon S3 in the back end, and then for processing using an AWS Lambda, which of course are super lightweight and easy to work with, and then adding DuckDB inside that Lambda, which there is no more lightweight and fast tool than DuckDB out there. It is the next hot thing. I mean, why pick DuckDB? Well, it's pretty obvious. You can pip install it anywhere, anytime. It's super lightweight. It's fast. It has no centralized configurations or metadata. There's a lot of powerful integrations DuckDB has built for cloud storage, databases, etc., etc. And of course, that means we can use it for Delta Lake. Also, DuckDB is super flexible, which is kind of rare in a tool. Usually tools are specialized, but DuckDB, you can do analytics, you can do general ETL and data pipelining with it, you can write SQL with it, you can have data connectors via integrations that connects with things like Postgres, S3, Delta Lake, Iceberg, etc. So it's a super versatile tool. And again, if you look at this picture, what we're really trying to get at is that when we're looking for a simplistic or minimalistic data stack here, in this case, with cost and complexity going up, you see you've got Snowflake, BigQuery, Databricks, Redshift, all those super heavy tools. There's a lot of infrastructure work that goes around those tools. They're very expensive to run. Why not go back up and lower complexity and cost by simply using DuckDB and AWS Lambda? So basically, I wanted to build a conceptual data flow and pipeline in real life on my AWS account to see if this would actually work. Basically, this is what it's going to look like. We're going to have a raw CSV file coming in. It's going to land in an S3 bucket. At that point, we will have an AWS Lambda that will trigger when that file hits the bucket. That Lambda will run some DuckDB and it will write to two separate Delta Lakes. In our case, we're going to pretend like we have a lakehouse that includes sort of like an accumulating table, like a fact table that just takes all the raw data from that flat file. The Lambda and DuckDB will just take that raw data and shove it in that lakehouse, and then as well there'd be like an accumulating or analytics type table that will basically what'll happen if we have these files hitting daily and multiple files. The idea of the second table is it kind of like a running cumulative table for a daily roll up, if that makes sense. This is kind of like a real life scenario. Many data pipelines run like this. Let's see if we can pull it off with AWS Lambda and DuckDB. So kind of the task I had to start with right off the bat was, of course, we'll have to create an AWS Lambda. Of course, we'll need a Lambda trigger when we have our CSV file that hits the bucket. We'll need our AWS Lambda to trigger. We'll also have to create two Delta Lake tables that are stored in S3. One is like an accumulating table of the raw data, and another one is like an analytical table. It's a roll-up of daily values. And of course, we'll have to write the DuckDB code to make this all work and run inside Lambda. By the way, all this code is available on GitHub. Go check it out if you want to see a closer detail of what happened. The very first thing I did was create a Docker file and put it up in the ECR, the Elastic Container Registry in AWS, so we can use that for our Lambda. That's where we're going to put our code. That's going to be what runs inside our Lambda, is what we package in this Docker file. We're going to store it in the Elastic Container Registry on AWS. It kind of makes it easy to productionize this sort of workflow. Look how simplistic this Docker file is. There's not much there. Amazon provides base Docker images for just about every kind of language, including Python, so we just use that. We baked our credentials in there. Of course, you could use roles and things like that, and I just ran a requirements text file to install things like DuckDB and Delta Lake. And of course, then in a Docker file, we're just calling our Lambda handler function, which is just a normal thing you do, an entry point for Lambda. Building this Docker file is super easy. It's just as simple as that, running that command. Of course, we could automate this in a build system and GitHub Actions or something like that. If you're curious what's inside the requirements file, this is what it looks like. It is nothing fancy, just a few Python packages. Now, we needed some data to work with in our toy example. Of course, I used a Backblaze dataset, a hard drive dataset that's open source and free. You can go check it out. It's kind of nice. And this is kind of what the file looks like. It's just basically a bunch of failure indicators for hard drives inside data centers, and this is what it looks like. It's a big giant mess, which is good because that makes it, realistic for real life. Of course, the next step is going to be creating our Delta Lake tables on S3. Remember, we're going to have two of them. One that is going to be a general accumulating table, like a fact style. So it's going to take in that raw data and build it up over time. And then the second table is more like a cumulative table or data mart style, where it basically stores a single record per day. So it kind of holds like the roll up there. And now we're going to have to basically interact and calculate all these tables with DuckDB inside the Lambda. To go ahead and make my initial Delta tables, I basically used Daft because it has some really nice built-ins with Delta Lake and just made it really easy. I just kind of read the CSV file, as you can see there. It does pretty good at, indicating what the data types look like. And you can see the code here. I'm just reading one of the raw files. I'm getting the columns I actually want to keep, throwing away a bunch of them, and then just writing the Delta Lake out to S3. And that's going to be basically our fact table. It looks pretty normal, right? A date, serial number, the model, the capacity of the hard drive, did it fail or not, etc. Also, you can see I'm creating the second accumulative style table there, which is, from a dict in Python with a date, a model, and the failure rate, because remember, it's accumulating table, so it's just going to hold the running failure numbers that we had for a certain day. Now that we have our Delta tables up and running and we have a Docker file that will work for our AWS Lambda, let's go ahead and write the DuckDB code and see what actually the core of this code looks like to do this sort of pipeline and see how easy it is. Of course, in this Python code, we're going to go ahead and indicate where the Delta tables are, the two separate ones, one for the raw table and one for the cumulative table. Easy enough. We go ahead and get the credentials from the environment that were baked into the Docker image. Of course, this Lambda is going to be triggered when a file hits S3, and when that happens, if you don't know much about Lambda, that context is handed off to the Lambda automatically. So in this case, we're getting that context and we're pulling out the event name and key. So it's basically the bucket and the key of the file that just showed up in S3. That's the file we want to process into our lakehouse. Of course, using DuckDB is pretty easily. We just start a DuckDB connection. We can run a query where we kind of load and install some stuff and some secrets that allow DuckDB to work with AWS. Of course, what we do, we have a list of columns we want to keep, because remember that table, the cumulative one, and the fact one, we don't want to keep all that data, just a little bit. Next, we have a query here in DuckDB where we kind of create a data table of this. We create a data table of what this file is on S3, this raw file that hits. And you can see there in DuckDB, it's real easy. We just read from CSV and we just pass in the S3 location. And it basically reads that raw file into a data table in DuckDB, and we convert it to arrow and arrow data frame. And after do that, we just call write Delta Lake, and we go ahead and pass it the Delta table path where we want that data to go. We say mode is append, we're just appending the new raw data, and basically pass it in that arrow data frame, and away we go. Wow, easy as that. It's dumping that raw file right into our accumulating table. That's pretty nice. Of course, we need to start doing some logic to build up the cumulative data for that table for that day. We have a cumulative table, Delta table, lakehouse, that basically is a record per day and then the number of failures we've had that day. So that's going to mean we're going to have to read the Delta table as it currently exists when that file comes in. We're going to have to combine those records from what currently exists in that table with the new incoming records and then write that result back out, if that makes sense. So easy enough. We create a current table. Again, from the Delta scan there, we're scanning that table as it exists and pulling in that information. And then, of course, what we can do is, again, we can union the current data that we just pulled out, remember, in that Delta Lake table. And we can also pull in the data. We can pull in the result from the data table that we created earlier. That's the current records that come in. And we can go ahead and basically sum up the failure rate and group by the date and model. So we're kind of, rolling up there. I guess I spoke wrong. That cumulative table is by date and model because we want to know how many hard drive failures we've had per day per model. So we have the current data in that cumulative table. We have all the new data that just came in that we just read from that raw file. We smash them together, group by the date and model, and just do the simple sum. And then, of course, we pull that back out to an arrow table, arrow data frame, and then we go ahead and basically send that back into the Delta Lake. Of course, this Delta Lake is partitioned by date. So we pull the date partitions that were in that file because we can't assume it's always today. So I'm going to go ahead and I went and selected the distinct dates from that table, which was created from that raw data that just came in. Get those date partitions. As long as we get that date partitions, we can kind of build a list of those dates that is expected to be passed in when we write that Delta Lake table out for the cumulative. You can see there. We went ahead and say write the Delta Lake. Here's the table path. Here's the cumulative data frame that we rolled up, and it's an overwrite mode. So we're going to rewrite those partitions that are showing up in there. We add the partition filters, which is basically the dates out of that data frame we're passing in. The engine is pi arrow and the schema mode is overwrite. So overwrite that partition with the new data. That's not too bad, is it? It's pretty straightforward to follow along. Pretty typical data flow. I mean, you can see there's a little complexity there, but there's no more complexity than you would have in any other system, say if we used Databricks and PySpark. This is a very common use case where we are ingesting a flat raw file data, things like CSV and text files, right? And we're putting them to a lakehouse. This is super common. Let's talk about this a little bit. What's the use case for this? Well, these Lambdas are a light solution in the context of architecture. They're also simple to maintain and automate. Building the Lambda and deploying it out into AWS, that's super simple. It can be automated with any sort of Circle CI, GitHub Actions, etc. Also, DuckDB made it super simplistic to read remote S3 files. Those flat files were really easy to read, weren't they? And DuckDB is also really easy to use to authenticate to AWS. It was also had the ability to materialize those queries as arrow data sets. And PyArrow is very versatile, which it makes it easy to interact with other tools like Delta Lake. Also, DuckDB did have the ability to read that Delta Lake remotely, and we were able to write back out to it. And also, DuckDB has a sweet ability to run complex SQL statements to manipulate data pretty much in any way you want. This is a creative, cheap, and easy and lightweight solution. I did go ahead and test the solution. I went ahead, you can see, and I made a ECR container registry out there, and I went ahead and pushed and built my Docker container. As you can see, just a couple commands. You can build the image, you can log into your ECR, and you can go ahead and push that Docker container out there. And once that's done, of course, there's a million ways to create Lambda function in AWS. You can automate it. You can do it through the CLI, Terraform, whatever. I went ahead and just did it through the UI just to get it done quickly. I just selected container image, went ahead and selected that new container we made. All I had to do is then add a trigger, as you can see, to my bucket, to the prefix in there for my raw data was going to hit, suffix of CSV file. Went ahead and uploaded one of my sample files up into that bucket. Went and checked the logs. I could see the Lambda was going ahead and processing that file. The trigger worked, kicked off the Lambda. And I went to see, how do I know it's going to work? I go over to my, basically the location in S3 of that cumulative Delta table to see, there should be new data, new partitions in there. And there you go, voila, there is new partitions in there. Went ahead and wrote the data into that lakehouse in S3 in Delta Lake format. You can go ahead and look at that data in those lake house tables in code, and sure enough, there is my cumulative table, has a date, a model, and the failure rate that happened for that day on that model for the hard drives. Wow, just what we wanted. I mean, you have to admit that's pretty slick and fast way. A lot of people look at this sort of lakehouse architecture and they automatically default to super complex sort of architectures that are heavy, costly, and require a lot of work. And I'm not saying you don't need those. I have designed and built and run many of those systems today that are like that with Databricks, etc. But I also want to balance that with just showing how easy something can be. You don't always have to jump into the deep end. There are options. Everybody's talking about the lake house. It is the future, and we think that comes with a whole set of tools and complexity. I just wanted to show that there is other options out there. And also note, if you do need Delta Lake concurrency for multiple reasons, right, there's a DynamoDB model to do that. But of course, I just wanted to show you that there is such thing as a minimalist data stack, a lightweight data stack. It just takes a little creativity. We just showed you how with AWS Lambda and DuckDB and Delta Lake, you could build a very cheap and fast lakehouse for yourself in no time. Thanks. Let me know what you think in the comments.